Hello guys. Ooh. Hello guys. So I'm starting to stream a little bit early here. Just want you to rate how's it looking for you in the chat. Hello everyone. Oh, that's awesome. Thanks, Jack. Nice. So, anyway, hello. My, was it? Oh my goodness. My, the UI is so small on my other screen. Correct me if I'm wrong, but this is Mistletown Productions. Says hi, says hey. Hi, Mistletown Productions. Okay, so this is the plan for today. I've got homework to do, and I got this. Thanks, man. I got homework to do, and I'm going to be surprised doing it. But also, I'm going to be watching this video tutorial of my teacher, and my face cam's off. Also, might be eating some dinner while this is going on as well. So, might be some nice ASMR of me just going. Getting extra weird on stream. Okay, so whenever we're ready, we could get started. Sorry, yeah, I'll chew a little bit louder, but I got food right here, so I'm just gonna have a little bit. Gonna have a bite of this. It's a bit of shepherd's pie on a plate. Is this loud enough? Okay, I'm sorry. Let's not go there. But okay, let's get started on this. So currently, for anyone who doesn't know, I'm going to be doing some graphing stuff, so then that way we can... Worcestershire sauce? I don't know. But I'm going to be doing some graphing, and this is going to involve stuff like pathfinding, A-star later on. But so far, I'm a noob, so I still got to do the basic stuff here. So anyway, let's get started into this video. I've already started a little bit, so you feel free to follow along. When it gets to the part that I'm up to, we'll stop, and I'll stop the video, and then we can code together.
On our process of graphs. So in the last video, we talked about what graphs are. In this video, we're going to start.
Also, don't worry, I asked him for permission to use these videos on stream, so it's all good. Let me know if you think I should make the video bigger for this bit.
Talked about stuff in Photoshop. We identified that nodes.
Maybe just for this bit.
Some sort of arbitrary.
I'll barely hear the teacher. Oh yeah, let me quickly fix that. Okay, if we make that go up. That's not it. Quickly going into Audio Manager here, boosting the volume of Chrome. Sorry about that. Very sorry. Okay.
Some sort of arbitrary.
Can you hear that?
Right. So, what we want to have is the ability to have a generic graph class that can have.
So let's move this all the way up
in each node, and then generic data stored in each edge. And so we're going to build up a very, very basic kind of
there we go
graph class that is templated to store that customized data that will be applicable for all sorts of things. Later on, we're going to work and create a 2D graph class, and that will be where the nodes and the edges will represent. So the nodes will represent a position as a vector 2, and the edges will represent a cost, and that cost will be the cost of traversing from one node to another node for our pathfinding algorithms. So we're going to build a generic graph class that can store any amount of data, and then we're going to extend upon that for an explicit 2D graph class for the purposes of our projects. So what I want to just quickly break down is the class diagram for that we'll have our graph class.
Also, one thing I'd like to do, just to interrupt this video, is I want to thank you all for coming here today as well. Oh, hi, Mickle! Oh, it's like, yeah, I'm doing my own homework. You can do your homework too. Oh, you've already done your homework. Okay, nice flex. I got plenty of homework, so I got plenty to stream today. So I just wanted to say thank you all for coming. Just one more time. Just want to say how much I appreciate it. We are currently over 50% of my most concurrent views, which is awesome. And by the way, that means I've had 4 concurrent viewers as my maximum up until this point. So I want to say thank you, all 6 of you, and the last 4 of you for joining the stream. For the yeah, boy, this is epic homework time. Epic homework time. This is the best homework time. Rip. Okay, let's get into it.
And this will be templated, so we'll have node data and edge data.
Let me know if there's anything you don't understand in the chat.
This will be a class. And then what we'll have is a graph2D class that will inherit from that. And this graph2D.
Okay, well, EMC squared is actually a constant derived by Albert Einstein, defining how mass has energy and how mass is like E equals mc squared is actually the equation to get the mass energy of an object. So I know it's not a coding question, but I do want to flex my physics knowledge.
B class will be the one that
Minecraft, no, E does not equal Minecraft 2. I don't know if Mojang will make one, but that would definitely be funny to see a Minecraft 2.
we have for our generic 2D positioning nodes and edges. What we'll then have later on is a graph2D editor. And this will be a class that has an instance of a graph. So our graph2D editor will have an instance of our graph, and it will be responsible for rendering, and it will be responsible for detecting mouse clicks and updating that graph. So update. And then our application will have an instance of our graph2D editor. And so we'll be able to create our 2D graph. We'll have all the ability to add a node, add other nodes, and connect nodes together. And then we'll have the ability to create an editor class that will manipulate that data. So that's what we're going to work towards. In this video, we're just going to focus on creating the templated version of that. So open up Visual Studio. In the last walkthrough, what we left off with is our player that can pathfind around the screen. Sorry, not pathfind, a player that can seek towards a target around the screen. So this is what we left off with in the last video. Now I'm going to get rid of, remove that logic because they're in reusable components. We can add it back in. What I'd really like to encourage you to do is implement a game state manager. There's a video tutorial that you would have seen earlier in the year.
I haven't done that yet. I'm sorry,
implement
sir.
the game state manager into your project, and then you can separate all of your different AI demos into the single project, and you can keep that one project as we go along.
Yes. Yes.
For now, what I'm going to do is I'm going to open up application.h and application.cpp, and I'm just going to get rid of my player object so that we can start from a fresh slate. So I'm going to remove my player, remove my player from the update, and I'll remove my player's draw. So with those few lines, what should occur now is you'll have an empty window. So this is where I'm going to build off for today. So first thing I want you to do is in your project, right click on the include folder, add a new item. I'm just going to call this graph.
Hello, graph. Not gonna lie, typing ASMR is,
private.
I know, I'm pretty sure it
I'm going to
exists,
give my
and it is
graph
nice.
a constructor and a virtual destructor. The reason it's virtual is because I intend on having inheritance with this. Alright, so that's the first thing, is constructor and destructor. Now, we already mentioned that we need to have a data structure to represent our graph nodes and a data structure to represent our graph edges. So I like to list them up here. So we'll start off with doing nodes. If I want a node, I'm going to say struct node. A node needs to have some kind of data. So let's say that our node contains int data or some other sort of thing, whatever. Just know that the data type here of int, that needs to be changeable later on. Our node also needs to have connections to other nodes. And so what I'm going to do is include vector so that we've got our dynamic array library. And let's say that we have an std vector of node pointer connections. So far so good. What this represents though, if we just have a node with an array of connections, this is fine because we can, where's Photoshop go? What this will represent is we can have a node and another node, and this node can have a connection to another node. The problem is we want to be able to store a value on this node, and so this edge, this connection, actually has to be its own data, its own class with the data that it's storing. So instead of having this as a vector of node pointers, I'm going to create another structure. And we're going to say who is this edge pointing to, and what is the data for our node. So edges have data and nodes also have data. Now I want to customize this int and this int, so we're going to make this templated.
Yeah, templates, very useful. A little bit of a hassle, but very useful.
T edge data. So this int is going to be a node data. This int is going to be an edge data. And now our edges, our nodes connections will be based upon edges.
Look at all that
the
edge.
only thing here that is an issue now is edges have a node instance. A node is defined above, but node also has an edge instance, and that's defined below. So we actually want to
Was that circular referencing? No, it doesn't quite work. So we need to predefine.
just above, and that will solve for that problem. All right. So the functionality that we want to have in our graph. So just again, if I jump into Photoshop, our graph, this whole canvas is our graph. So our graph needs to have a list of nodes and then the functions to add nodes and to connect edges. So let's create an std vector of node pointer nodes. So this is just our collection of nodes for our graph. And now we want to have some helper functions to help us manipulate this collection. So let's create a function, node pointer add node. The node that we want to initialize it with, we want to initialize it with some data. So const tnode referenced data. So this method will go about creating a node instance and then adding it to our list. We also want to have a function that connects two given nodes together. So have a method that returns void add edge node pointer node A node pointer node B, and then the edge data const t edge data. So these are our methods that we'll have for our graph. Because it's templated, that will mean we need to write all of our methods inline inside of our header file. So I'm going to scope these out. And just for readability, I'm also
and say, okay, so this is the bit I'm up to. So we're going to do
method so that it's
we're going to activate the mini player. Going to go right there. So now we can follow along with the video tutorial while I'm doing the tutorial.
It's really easily identifiable where one method starts and when another method finishes.
Okay, so we're gonna.
This is our constructor.
Okay, so he's doing that. Okay, so we type in. We make things nice and obvious for the people at home, for the people who are going to be working on our code. Structor. Is that? Yeah. Okay, I can't spell. So please don't kill me.
This is our destruct.
This is our destructor, and then I'm assuming he's gonna do an add node method, and he's gonna. I mean, the next one's gonna be add node, and the next one's going to be wait. Ooh, oh, goodness, what have I done? I just need to press tab. Okay. As you can tell, I am a pro at coding. What do you mean this takes me 30 minutes to do like 2 seconds worth of work? That's ridiculous. That's ridiculous. Okay, then destructor.
This is our add node method.
There we go. Just the words we were expecting to hear. Our add node method with some problems still. See, right. Add node, and then the next one's going to be add edge. Yeah, boy, let's get extra edgy.
And this is our add edge method. So now we just want to populate this. Our add node, what we want to do here is create an instance of a node object. Node pointer node new.
Okay, let me get started. Add. So we need to add. So node pointer node equals new node, and then
node.
Awesome. And then
node arrow data will be equal to data. So that will be the data that we pass into this graph class. Then
also a nice little note. If any, so do the coding thing. Yes, I'm doing it. I cut myself in all that edge. Yes. So just for anyone who doesn't know, I'm pretty sure I won't need to say anything because everyone here is either from the coding course or is probably doing some coding. But normally to like get to access data from a class, you just put a dot. But because we're referencing a pointer that is cast as a node, we have to use arrows instead. And just a little bit of knowledge, going into this.
What we want to do is just add that node to our list and return the node that we created.
Yeah, boy, this guy works fast. Look how fast he works. I mean, he's been doing it for way longer than I have, that's for sure. Yeah, so our m nodes is right down there.
Node function. Our add edge function is going to do pretty much the same thing.
Okay, now this is where things get edgy.
Edge. This time though, I want each node just to have its own list of edges, not pointers. So I don't want to create these. I just want this to be a continual list. Because I'm using structures and plain old data, I can actually initialize these in line. So I could say edge E is equal to node B. So this is our 2 and data.
Yeah, that's always the weird thing about like structs and other classes, is just that you can, this is how you enter data into them. You have to do equals curly braces when it's one of those things where it takes in more than one instance of data. So like, you know how in int you can just say int beef is equal to 1? Yeah, so if you have a struct with like more than 2 things, you have to use curly braces. Or is yeah, it's curly braces. You can't see it. It's probably a little bit small on your end, but it's definitely curly braces.
So node B represents our 2 and data represents our data. So we can initialize our structure in this way. And then what we can say is node A arrow node A arrow connections dot push back edge. So I'm not sure why IntelliSense isn't working here, but
oh wow, we got the same problem.
This is just a vector of edge objects. And so what we can actually do is, instead of creating it here and then passing it in, we can actually just make this a single one-liner.
Oh, yeah, so this is where he goes ahead and just completely dumps on all of us. Just saying, okay, so we'll do this, and then it's like, actually, do you know what? We won't do that. Here we go. We'll do this instead. And it's like, okay, cool. I mean, on the fly. Got to give him respect though. On the fly kind of stuff.
So this is actually our add edge function. One more thing I want to create, and that is a getter function for our nodes. And this one I want to return a constant reference to our vector. So let's create one more function, get nodes, std vector of node pointer. We want this to return a reference and we want it to be
okay. Getting a head start on me, pal. Okay, get nodes, play, get nerds. Let's get nerds. I don't know.
constant.
Okay, so we want a constant.
Nodes. And this is just going to return m_nodes. So these are just the basic functions for our graph.
Whoop, damn, missed the part where it tells me exactly what to do. Oop, nope. And percent instead. And we call that get nodes. And then oh boy, what did I do there? Return m nodes. There we go. Whew, let's go.
So these are just the basic functions.
Now one thing I do want to do is just give it a quick run, give it a quick build where the error's at. Because that's probably why IntelliSense is not working, because there's going to be some problem. Oh yeah, oh boy. Okay, so I'm going to turn system volume down. That's still way too loud, what the heck? Okay, that's better. I didn't actually read the error. What did it say the error was? Error, unable to open file. Oh yeah, I don't think I haven't built this new stuff yet, so I have to rebuild the solution. Okay, it's rebuilding and everything is successfully built. Now when we hit play, what it's going to do is it's going to see what we've done so far. If it'll allow me. There we go, done. Yeah. So one thing that you can do if you are getting annoyed about how it doesn't build when you play, you can go into here, configure manager, then here you'll see some, damn it, it's a pop-up. Okay, so gonna have to quickly open up, because I'm too lazy to actually do a normal thing. I'm gonna quickly open another window capture just for this. Okay, so it usually appears somewhere in the middle of the screen for me. So then you see that it's right in the middle here, and then you can choose what options you want on your configurations. Now, probably if you're going to be working on a whole bunch of different projects, and for ease, just select build all. Some of them you probably won't need to build because you're not editing those, but I will be editing some of these later on, so I'm just going to tick for all of those ones. Not entirely sure what deploy does, but that's deploy for you. And now it's going to pick up my audio manager. Let me get rid of that. Awesome. So yeah, now that means when I hit play, it's going to automatically rebuild, and then it's going to do that. Just saves you a little bit of hassle when you hit play and then it's like, bruh, this isn't up to date, bruh. And then it's like, sure, it's a little bit annoying, but it's better than making edits and then having to do it manual. I mean, why am I saying it's annoying? It's great. It's perfect. Exactly what you want it to do.
Functions for our graph.
Mm-hmm.
It's templated. All right, cool. So let's just check that we can include this in our application and make use of it, at least in this a little bit. So we'll say
Now this bit, since I haven't done the game states thing, this is gonna look a little different. But as long as you get the gist, which is what I'm trying to do here.
Include graph. Let's pre-declare it in our application class as well. So we can pre-declare our graph class. Actually, I'm gonna skip on that because we're just gonna move on to better later. Actually, so we'll create a graph. Let's just test that this works. So graph my graph.
Better graph my graph.
Dot.
So I'm pretty sure we'll just put it in initialize here. Might as well. So we'll do graph my graph, and he's gonna have to explain to us why it's currently not working, and then he's gonna be like my graph
so this needs to be, let's make it with vector2.
Oh yeah, because it's a template class, so you need to tell it what it needs to be.
Floats.
Vector2 and floats. Awesome. Bam.
So the nodes have an object of vector2 and the float has data, sorry, the edges have float data. So my graph dot add node, let's say 100, 100. And we can say auto node A.
Oh. I'm not actually very used to using autos. Never really use them. I guess it's easier to just use auto.
Should be equal to that. So this should be asking for add node. Oh, all right. So this is a problem. T edge data. I mistyped that. So add node needs to take in
node data. That's how I didn't notice that the first time. Is pretty hilarious. Okay, that should fix that.
Node data. So it's my mistake there. You guys probably spotted that ages away, and you've been yelling at your screen. This won't compile.
No, don't worry, man. I'm with you.
So,
I was dumb.
Be my graph dot add node. Let's add another node. Let's say 200, 100. So now we've got 2 nodes. Let's add a third. Node C, 200 and 200. And let's connect some of those edges together. So my graph dot add edge, node A, node B. Let's just give it a cost of 100.
Oh, accidentally picked to add edge there. There we go. Now let's give this some space so we can do my graph add edge. Yeah, boy, this is gonna get real edgy. And then, bam! I'm gonna finish off a little bit more of my shepherd's pie. Mm.
100. Node A and node B. We need to do it in the opposite direction as well. So
Opposite direction as well.
node B should be connected to node A.
And we need to do this 3 more times for
us,
the other
what
nodes.
we're modeling here
Okay.
is we've just gone about creating 3 nodes.
Mm-hmm.
Those three nodes, we've got, this is node A, this is node B, this is node C, and we've just said create a connection from node A to node B. This is a one-way connection. And then on the next line we said let's create another connection from node B back to node A. And so now we can do another one to connect these two. So now let's go from node B to node C, and node C to node B. Let's build this and check that it works.
Let's go back 5 seconds to see what was going on. I don't know why he didn't just change where A was and make it C. It's about the same deal.
Let's build this and check that it works.
Ooh.
And it does, it compiles and it builds.
You don't see it right now, but okay, should have definitely just done screen capture because now this is getting a little bit on the annoying side. But yeah, this is what we got. We got ourselves a little error message. Woohoo! We did something wrong. Woo! Okay, it says nodes undeclared identifier. Ah, yeah, should change that. Okay. Oh, yep. Semicolon. I swear. It's loading. Okay. Okay, you can't see it, but it's definitely output to console. And that marks the end of me actually trying to use window share. So hold on, let me quickly edit this stream for just a sec. There we go. Look at that. Awesome. So, here we go. So now we can see the whole screen. I just wanted to do screen share because I know, a little bit thick. Okay, so we got everything. Awesome. Let's move on to the next bit.
There's nothing for us to really validate at this point in time. So I'm going to leave it at that. And I'll see you in the next video.
We did it, boys. We got to the end of the video. Yeah. Wasn't that intense? Wasn't that epic? I don't know. Okay, so now that means we can move on to the next video, and that is number 10, the graph editor class. Now the graph editor class video is going to be hopefully the one where we can get something to output to console, and then it's gonna be fancy. Apparently there's at least 2 more videos on the graph editor class, but it's going to be all worth it, I assure you. Also, a nice little neat feature when the video starts to play is that you'll see, I'm pretty sure he did it like all in succession, which is really nice. I do like how he split it up. Certainly makes it more manageable. I know that when I was going through another coding course when I was in year 11, it was like, they gave us like a couple of videos that were like 2 hours long, and they wanted you to watch them and like over the course of a week. And I was like, bruh, it's like, they're like, why are these videos so long? And why you gotta make us watch like, I mean, it's like, it was like up to like 5. I think the most I saw was like 5 or 6 videos that I had to watch, and like they were like 2 hours long. I'm like, come on, I can't. Like, I like coding, but I can't. I'm not watching 5 movies dedicated to coding.
Hi everyone, welcome back. In this video, what we're going to go through is extend upon our graph class that we created that was templated, and we're going to extend upon that to create a graph 2D class that's got functionality that is specially built for graphs that have nodes of vector 2 with edges of floats. So
now, before we get started, actually, just in case, I actually do want to see what was that thing that he wanted us to do just before this? He wanted us to do a game manager class. Oh yeah, game state manager. Yeah, so I'm also going to have that open in another tab, because it seems like some of the stuff in here is going to be covered in... Oh, wow, it's 1 hour and 16 minutes. Okay, well, if we must, we will do that, but maybe not. Maybe on this stream, maybe not on this stream. I still want to have a nice night. It is a Friday. I was thinking maybe only an hour of programming, but looks like looking at an all-nighter. No, I'm not gonna push myself. It's a Friday night where we're up all night for good fun. Come on, Justin. Don't make me do that. You let Aaron down. No. I don't want to let Aaron down. Is he in the chat? Is he watching over us? The great Aaron. Yeah, that song by Daft Punk. You know what I'm saying? Okay. Well, we'll get started. Let's get started.
So we're going to create a special graph 2D class, particularly for the use case of pathfinding later on. This is particularly important because with our current setup, we can have graphs of std string to std string.
He does 4 a.m. for us. Least he can do is 6 a.m. for him.
Float and float, or any sort of.
Yeah, I'll start at 6 a.m. tomorrow. So that's what I'll do.
Custom graph 2D class specifically for nodes that have a vector 2 representing a position. So vector 2 float. So that's what we're going to initially create. Once we've done that, we're going to create a renderer class that allows us to render our nodes and edges on the screen.
This stuff gets hot real
to
fast.
Get started with this, right click on your include project, on your include folder, add a new item, header file. I'm going to call this
okay. I don't know who calls it an include folder. I mean, as far as I'm aware, it's always been the header folder, but I guess we'll just put stuff in there.
graph 2D.
And I thought I was gonna call it graph renderer, but no, graph 2D. Let's go, Mia Mario. Let's go pragma once this bad boy.
Because we're going to be inheriting from our existing graph class, we will include graph.h. Graph, create our graph 2D class, inherits public from graph of vector 2 and float.
What?
We don't know what vector 2 is, so we will need to include ray math to get our vector 2 class. Public, protected, private.
And then that is publicly inherit why, I wonder why it has to be a specific float. I think that's my question. Do you know why it has to be a specific kind of graph it inherits from? Because you see that he specifies that's not just graph, it's graph of vector 2 and float. Oh well, oh yeah, and then we have to include ray math. So we ray math. Bam.
Now for the moment,
yeah, so if anyone in the chat can help me out here, why does it have to be specifically this kind of graph? Does that mean that other kinds of graphs, I mean, I know other kinds of graphs probably wouldn't work with the rendering, but I mean, does that also mean that like you can have different classes based on other stuff? I don't know, it just seems very weird.
I'm just going to say we want a generic constructor and a destructor. The destructor is virtual because we're using inheritance. So
Okay, wait.
let's just stub out the body for our constructor and destructor in our source files. Graph 2D.
Okay, so now things are about to get saucy. Why is it giving me squiggles? Function definition for graph 2D not found. Oh yeah, that's because it's coming up. So go into our source files here, we go add new item.
include graph2d,
Me trying to find the hash key.
populate these. All right. So now we have our graph2d class. What this should allow.
Well, I missed almost all of that. So then it's graph2d, and graph2d, and then graph2d tuple, and graph2d. Wrong ones. There we go.
All right. So now we have our graph2d class. What this should allow us to do, if we jump into our application.cpp file that we were working with earlier, instead of including graph.h, let's include graph2d.h. And if you come down to here, we should be able to change this to graph2d, and this should work exactly the same. So we'll run it and check that it still builds. And it builds, it's running successfully.
Okay, mine is still busy building. There we go, look at that. An output to console. Just the way we like it. Ooh, know what I meant to do. There we go.
So all should be good there. I just realized we have a memory leak. So this is jumping back to our previous video. There was a thing that I had forgotten about that. If we jump into graph.h, you'll notice in our add node function we are newing a node, and we are not deleting those nodes in our destructor. And so what we should do is loop through all of our nodes and ensure that we remove them. So for auto node in m_nodes. Delete node, and then we can say m_nodes.clear. So when our graph's destructor is called, it should go through and delete all of those nodes, which will free the memory that we've created here. That's a bit of a tangent, but cool. So we've got our window, we click close, it should all be going through. And one thing I should have checked as well is that if I put a breakpoint on my graph2d class, so that's hit, step over, step over, step over, step over. So we've got node A has data, no connections. If I step over, node A should now have a single connection, so that's pointing at node B. And node B's data, the edge, its data is 100, and it's pointing at node B, and that one has no connection. So if we step over node A, connections, come on, connections points to node B, which now points to node A, which now points to node
oh my goodness.
B.
No, I know I need to do that. Let's go all the way down. Okay, so now apparently I can hover over node A, open that up, and then I get connections, and then I open that up, and then so from, guess we open up 0, then we go 2, and then this is node B, data is node B here, and then we see a connection at node B, and then, no wait, so this is node B, no, this is node A, and then this is going to, no wait, oh hold on, this is funky, because you go in here and then you go 2, so we're at the edge, now we're at the node, now we're at the connections, now we're at the edge, now we're at the now we're at the node, now we're in connections, now we're at the edge, now we're at the node, now we're at the connections. It's really weird. Okay, that's fun. I get it. I do want to keep this going. Let's see actually, how long can we keep this going for? Connections 0, 2, connections 0, 2, connections 0, 2. Yeah, so this is actually I don't know, it's a bit funny for me. Do like oh boy, that was funny. Okay.
And we just continually go through in this recursive fashion. They're just pointing back and forth. So we know this is working. This is
awesome.
Working. What I want to do is I want to move this to become a member variable. So let's jump into application.h. And let's type in graph2d underscore graph. I'm going to pre-declare my class 2d, and this needs to be a pointer. So graph2d pointer mgraph. We initialize it to null, and so over here, instead of my graph, let's call this m underscore graph is equal to a new graph. We are a graph2d. So these will now all become arrow. My graph, arrow.
It's like my graph, my graph, my graph,
my graph, arrow. My graph, arrow. My graph, arrow. And again, now that we're newing our graph2d, we need to make sure that we delete it. So in our unload, we'll say delete our graph and reassign it back to null.
Okay, so we can actually do some of this stuff here. So before we close, when we close our window, what we can do is we can do the application unload stuff. So we can go delete. Look here, I'm just trying to make do with what I got. I don't got much, but we can make it work.
So ideally, this should still be working fine.
It must be a pointer. Well, can we do the address of my graph? Yeah, we can delete the address of my graph. Awesome.
All right. So our graph class working perfectly so far. What I want to do is actually create a separate class for rendering our editor, rendering our graph, or rendering our editor. So I'm making some changes on the fly here, so we'll see how this goes. In our include folder, click add new item, make this a header file. We're going to call this graph 2D editor.
So we have our graph 2D, and then our graph 2D editor. Okay, so makes you wonder. Sorry, never mind. Okay, I get it. I get it now. I get it. Oh my goodness, I spelled that horribly. Editoya. Oh my goodness. I'm gonna need to change the name. Oh boy. Let's rename. We need to rename that. That's editor. Is that how you spell editor? Hold on. Going to go into Google. How to editor. Yeah, it is editor. Never mind. There we go. 2D editor. And in your heart, baby. Wow. Okay.
Click add. Class graph 2D editor. Public, protected, private. Now just to give you an idea of what we're working towards with this class is we are building the capacity for our nodes and our edges to be rendered.
Let's quickly go back a little bit. Oh, he hasn't actually done the other stuff yet. Okay, cool.
Just to give you an idea of what we're working towards with this class is we are building the capacity for our nodes and our edges to be rendered, and for that kind of shadow node to be rendered where the mouse cursor is as well. And eventually we'll be able to click and add nodes onto the scene. So this is what we're kind of working towards at the moment. So what I want to have for our editor, I want to have a constructor. We want a destructor. For this, we're not going to inherit from it for now, but later on, if you do have inheritance, you should make the destructor virtual. We're going to have an update function. A draw function, and our editor needs to know about a graph object that it will be editing. So class graph2D, we're going to have a graph2D pointer graph and a getter and a setter. So
A getter and a setter. Then Okay, something's really weird. Graph. My goodness. So apparently we set the class up here for our graph 2D. That's weird. Why wouldn't we just include why wouldn't we just include the file?
Graph 2D pointer get graph and a void set graph 2D pointer graph. So we've got a getter and a setter. Update and draw
Where'd the
functions.
0 come from?
Should be good enough for now.
Now, before he moves on to the next thing. I think I've been looking at graph for so long, it kind of feels wrong to spell. Like, it looks wrong. Lol. Okay. Well, and that's the problem.
I'm going to copy this. We're going to add our
So we're going to copy this,
CPP file.
and then we're going to make a CPP file. Of course. So then we type in the legendary words 2D ed it or, and then slap it in there, and instead you do that. Oh, whoa, oops, never mind. There we go. We also got a, so we got to hash include graph.2d editor, and then we go back here, and then we're like graph 2d editor how did D get lowercased? And then if you can't tell, I much prefer the I call it the normal style. Or there's certain styles for how you lay out your stuff.
We called this graph 2D editor.
So it's all set up.
So we will include graph 2D editor, add in our scope. Scope, fill in the body.
Yeah, so he does it a lot faster than I do. That's smart, grabbing it from the other place.
Alright, and we're set. So I'll get graph, return m underscore graph.
Okay. Boom.
I'll set graph.
Okay, quickly check a thing. Hold on 1 second. Just messaging friends. Okay.
Graph is equal to graph. And now we're free to write whatever logic we want in our update and draw for actually rendering this graph. Alright, so save that. In order for us to get our graph editor to work, we first want to create an instance of it, call its update, call its draw, and then we can go about actually figuring out how the draw happens. So let's pre-declare our graph editor. Graph to the editor pointer and let's go graph editor. We'll assign that to null pointer. In our application CPP file, we'll need to include it. Graph 2D editor. And down here, once we've created a graph, we'll say graph editor is equal to a new graph 2D editor.
To a new graph 2D editor class. So then we do graph editor equals
class.
Will that work for what we're doing? You could very much be unhappy with that. Yeah, we'll call that, yeah, we'll just call it graph editor. Thanks, Scott. I'll see you around. Hopefully you had fun. Or doing your other stuff. Gonna check with a friend. Aw, too precious. Okay.
Our graph editor class, we want to set the graph to our m underscore graph.
So graph editor class, and then we go set graph. We set that equal to our my graph. So this is what you do when you're a little bit too lazy to do what you need to do. You just kind of go, my graph, talking about my graph, my graph. Okay, hold on, what does, yeah, so it wants a pointer, which is okay, because then we just go into main, instead of giving it a pointer, so instead of giving it the thing, we'll give it the address to the thing, which is a pointer, if you didn't know. So then
we want to make sure that we also delete it.
Awesome. So then okay, cool. So now what we're going to do is we can go into the bottom here, and then we can also delete the pointer to our graph editor.
We want to make sure that we call its update function.
So now in the update, so we can call it in here. So we can call it in here. So we'll go our graph editor, and then dot update. That's what we're looking for, and then we chuck in delta time.
And we want to make sure that we call its draw function.
So then in our draw bit, which we don't have, well, so then actually hold on 1 second. Let's slap it in here. So we'll probably slap it here. Get time, and then we can go here to draw. Somehow end up with an apostrophe in there.
So with those things in place, we should now be able to say, let's test if those methods are actually being called.
Okay, so now we're going to test the methods that are being called. Boy, this is really pushing. If you can't tell, this is really pushing my what is it? There's a word for what I got. It's really pushing my short attention span to the limit.
Include iStream. So let's say now draw std cout hello world.
Yeah. So std cout. I'll write hello chat this time. Be like, hello chat. Maybe a little bit of dank memes, melt steel beams. Whatever you like. And then std endl. I do think there needs to be just a slight tweak because of just what STD stands for nowadays. It's a little bit odd why they wouldn't change it to maybe just ST or SD. Still STD.
So what I expect to see in that drawer in our console,
yes,
from our Graph 2D editor, yeah, we're getting a bunch of hello worlds drawn. So
now if you don't know, yeah, so if you don't know, oh wait, we still have a breakpoint there. Never mind. So basically, in this, we have so instead of, drawing anything to the screen, right now it's just saying whenever you draw, just go in chat and be like, and say, dank beams melt steel beams. It's a pretty nifty function if I do say so myself.
What this will enable us to do, and get rid of that.
Oh. What does that mean? It says has triggered a breakpoint. And this is why you do things properly, kiddos. Otherwise, things might get interesting. Is it because there's nothing in our deconstructor? Yeah, so if we go in here, right? We're gonna give that a play, then we're gonna give that a close. So then we can step in here, and then what it's gonna do is go into our graph 2D. Okay. Yeah, so our graph 2D doesn't actually have a proper deconstructor, neither does our graph editor have a proper deconstructor just yet. So, I'm pretty sure that's what the problem is. It's just not deleting itself at all, actually. For the time being, I'm going to comment this stuff out. Then we can fix that later.
Is we can now go about doing some rendering for the graphs. We'll start off with rendering the nodes that are in our graph. So we want to loop through all of our nodes for auto node in.
Here we go. This is where the good stuff. Okay, the good stuff is about to happen. We're actually going to see something on our screen very soon.
Graph arrow that says pointer to incomplete type, so include graph.
I pressed tab. Thank you.
2D. Now that works. Get nodes. So we want to loop through all of the nodes, and we'll say for each node, let's draw a circle. this from our raylib methods. The exposition is our node's data's exposition. Now, if you remember, data represents the node's value, the node's data that it contains, and for us, the graph 2D, its data was of type vector2, so we can get that x component. Node data dot y. Radius, let's go with 8. 8 seems good. Let's do a color light gray. And I'd like to also draw some lines around it. Draw circle lines. Pretty much all the same stuff. Except the lines will make grey. So if we...
Okay. Awesome. Draw circle lines of 8 grey. Okay. Those do seem like some thick lines.
If we run this code
sure
with this in our draw function, what we should see...
Now this is the juicy bit. This is the juicy bit. This is the bit we've all been waiting for. Runtime errors. Yes, this is what we've been waiting for this whole time. Well, because I missed a semicolon. Okay. This should work perfectly now. And now we should get something to draw. We should get something to draw. At least 3 things to draw. There we go. 2 things. 2 things have been drawn. And they look like mini octagons instead of circles. What did I do? What did I do? So we take a look at our main here. We should get something at 100, 100, 200, 100, and then 200, 200, which is... Yeah, so we have 100, 100, 100. Then we got 200, 100. It should be like a reverse L. Oh.
Is the 3...
Yeah, we should be getting 3. We are only getting 2. Yeah, so we need to check our class. So draw a circle, draw lines, then draw a circle, draw lines, then draw a circle, draw lines, then that's the end of the loop. Then it should end the drawing. So we hit continue here, right? So now that means, okay, I will need to move the screen out of the way so we can see it. For some reason only one is drawn, and mgraph, it's off screen right now, but mgraph still says there's 3 nodes. I hit continue again, and graph still says 3 nodes. So why isn't it drawing them all? Ah, there we go. That's the problem. It needs to be X, Y. Okay, so what if, for those of you who didn't know, I accidentally, for those who are keen-eyed, I accidentally had this as X position, X and then Y, so they were all on the, they were all using X's instead of using XY's, so it was XX instead of XY. That was funny. Okay, so now this should work flawlessly. I did not remember to take off the breakpoint. There we go. That's the reverse L shape we're going for here. Actually, probably a good thing that actually I might have just figured out is you probably just want the project you're working on to keep rebuilding. I feel like maybe it's rebuilding every single thing. We'll see if that improves the build times, because the build times are absolutely way too long on this beast of a machine. Okay, awesome. Awesome, we are getting nodes on the screen, ladies and gentlemen. Nodes on the screen.
Nodes that we populated earlier. So these nodes that are here, we can see them being drawn.
Yeah, we could.
So this is great so far. What I want to do now is actually draw the lines. So in order for us to draw the lines, I want to do this as a separate pass. I want to have all of my nodes drawn and then all of the lines drawn. So let's loop through all of our nodes a second time. And then...
Okay, so he wants us to do nodes a second time. Okay.
Let's loop through all of the connections on each of those nodes.
For connections. Oops. So for auto, one thing that does get on my nerves a little bit, it's like boy says, okay, so we're gonna go connections as connection, because it's one connection.
Node arrow connections.
It's like, well, Black Betty. Bam-a-lam.
And then we can say,
I don't know why I said that.
Draw line from the nodes data's X node data Y
To
the connections to node data's X.
oh boy, isn't that a line full? So we have to draw a line from the current node's X position. So we get our node. Then we get our data dot X, and then we get our Y position, which is going to be the same stuff. Except we slap a Y this time. Then we get our connection dot to dot data dot x. My god, what the hell? This is absolute genius. And we're getting an error here. Too few arguments in function call. Oh yeah, we need colors and whatnot. Okay. What does he go for?
Connections to node data y. And the color, let's make it gray. Right, so if we run this, we should see
that it's going to look adorable. Okay, so it seems like it is still slow, even though I told it to not build everything. There we go, look at that. And definitely you should always draw the lines underneath the nodes. Okay. That's what I learned from that. Does it look like octagons on his one?
Alright, there we go. So now we've...
Yeah, so I'm going to quickly enhance image. Yeah, they still kind of look like octagons on his one. Not sure what's up with that. There we go, everything's nice and snug in that corner. Okay, yeah, so for some reason it still kind of looks like octagons.
We've got our nodes, and then we've got the lines drawn on top of that. And I think I actually want to reverse the order of our drawing. So yes. I'm going to say, let's
so we cut
draw
this.
All connections. Let's do that first. And then after that, draw all nodes.
You know what that'll look like?
So now we have nodes and edges, and they can be rendered. So I think that is a good spot for us to wrap up in this video. In the next video, we'll go about implementing the grid of nodes and placing them, and then after that we'll go about clicking in the screen and adding new nodes to our graph. Thanks for watching. See you guys soon.
Okay, so that is number 10 completed. And now we do have one more if you guys would like to see it. Okay. Well, we're going to try and go ahead for the next bit. Maybe in a minute. We're going to take a quick break, probably. In fact, this is probably a good time to actually... Yes, we've been streaming for almost 2 hours now, so we're probably going to actually do something very important, and that is to get up. So now it's very important to get up every hour because, you know, it's just good for your health, just to get up. Just getting up once every hour is all you need to do, just so then that way, you know, prevents, you know, this little thing called deep vein thrombosis, you know, the stuff that you get on airplanes from sitting down for too long. Yeah. So that's why it's important to always stand up. You know, stand up for what's right in the world. Stand up for yourself. I don't know. Maybe even do a stretch, you know? So maybe, you know, do some good stretches, like here. I've got a couch over here, got a chair over there, and, you know, you can sit down, maybe do some leg stretches here. I think it's very good to stretch out every now and again, you know. Sitting in one place can be very, very stiff. Make you very stiff. It's like I remember I could almost do full splits, and then I started sitting down, and now I definitely can't. And it's like, boy, high school, what it does to you physically. I think that's kind of like the old feeling you get, you know, when you feel old, really old. You know, you just kind of feel like, oh man. It's like, I remember, you know those times back in like the playground in kindy when you're like running around the whole day and now you're kind of like, how the hell did I used to do that? Well, sometimes I get puffed going up the stairs sometimes. If it's like 3 or 4 flights, not if it's just like a floor or something. I don't know. Okay. I'm gonna quickly put this plate away and then we're gonna get started. Okay. It's gonna take all the rest of my willpower for tonight to hold myself from playing video games or doing anything else. But it'll be worth it when I can finally make some good nodes. That this is the longest tutorial out of all of them. This is the 25-minute tutorial. So hopefully there isn't too much stuff involving that games manager that I should have done probably before this bit. But we'll get to it.
Hey everyone, so in this video we are going to go about laying out all of our nodes and edges in like a grid format. So we are going to hopefully get as far as completing the project and implementing the rest of our demo. So we should be able to click on the screen, add nodes and edges and all of that stuff. So this is
I think that from what I understand, with the implementation right now, I don't know what the problem was exactly. I just know that he was having trouble using. So there are algorithms that you can use to traverse nodes and figure out the shortest path, to and from nodes. But he was having trouble getting it to work using this. So I'm not entirely sure whether the fault is in this part of the program or the search part of the program. So that's going to be up to, I don't know, whenever I get to that point. But just keep an eye out for that on your, tutorials. Make sure they're always good.
What we're aiming for by the end of this video. Now, the first thing we need to know is how can we place nodes at certain positions in a grid-like format. And so you can see here I've got some nodes, some rows, some columns, and then there's a certain amount of spacing in between them. So what we're going to do is just set up some really quick and nasty code to be able to slap some nodes down there.
Oh boy, quick and nasty. I don't know if I like the sound of that.
We come up to our load function.
Oh boy.
We'll get rid of add node, add node, add node, add edge. We'll get rid of these.
Oh boy. Okay.
We're going to start to write our own code to loop through. So I want to say how many rows of nodes do we want? Num rows. Let's say 8. Num columns. Let's say 6. We want to know where the x offset should be. So how far across from the screen should the first node be? Float x offset. Let's make that 100. Float y offset. Let's make that 100 as well.
X offset and float y offset.
And so now with these values, what we can actually do is loop through our rows and loop through our columns and create a node at each of those spots. So we'll loop through each row first. Y 0, y is less than num rows, y plus plus, and then we'll have a nested loop. X is equal to 0, x is less than num columns, x plus plus, and we should now just be able to say graph arrow add node
num cols. Then we get our mgraph. What is our mgraph? Uses that okay, that's our graph.2d, which is my graph, which is my graph. Dot add node. And this is when we let the magic happen.
We want to create a vector 2 here. And
Ooh.
so
why is he doing that? Why is he making it like that? This is making me uncomfortable. Why is he doing that?
what is the position of the node that we're going to create? Well, this will be our x position. So our x index, so that'll be 0 through to 1 through to 2. So that multiplied by the spacing between nodes. We don't have that. So float spacing, let's make that 50. So x multiplied by spacing plus our x offset, and our y multiplied by spacing plus our...
Yeah, let's just make it easy on ourselves and actually just change it to normal. Offset off, what? Well, it would just be x offset. There we go. And then comma y spacing plus y offset. Now it does mean that you could make it interesting and have an x spacing and a y spacing. Maybe you actually wanted like a 2x4 looking grid. Maybe, you know, just instead of everything looking equally spaced, it kind of looks really long. Maybe you just wanted, I don't know, you could just, I don't know, just make things either really long or really long or really tall, or maybe just you have like 10 nodes stacked on top of each other or going in a row, and then it's like, oh wow, look, they're on top of all. Oh, what am I working on? I'm working on graphing.
our y.
This is my teacher here. He's made a video, and I'm following it.
That should create for us all of the nodes that we want to have positioned on.
Okay, this is going to be a little scary for me, but let's see.
And it has, obviously here, I've got too many rows. So I'm going to make rows, let's make it four rows. All right, so here we've now got some rows. So we've got nodes per row and nodes per column, and they're all of them have been created individually in that loop.
Nice.
All right, so now what we need to do is actually
do the edges.
I want to search through all of the nodes again and find the nodes that are the closest to a position. So find nodes within an area. So if I wanted to have find nodes closest to the mouse, I might have a radius around the mouse that I'm searching for, and everything that is in that radius I want to receive those nodes. So we want a function that allows us to get nearby nodes effectively. So let's do this first. We'll stub out the code that we kind of want to have, and then we'll implement the function that we'll need for it. So we'll start off with, we want to loop through all of the nodes in our graph for auto node in graph.
Okay, so for auto node and then my graph, get nodes.
And so what we want to do is for each node that is in the graph, we want to get nearby nodes. Now we'll probably have something like std vector of graph2d node objects.
Oh, std vector of graph 2D node objects. Okay, so if what you don't know is that if you did not see the parts in our graph 2D object, we have a struct called node, and what we're going to be doing is grabbing the node inside our graph object and using that inside this vector.
Node pointers. Nearby nodes. So this collection is empty. We want a function that populates this collection with the nodes that are close by. So I want to be able to say something like graph arrow get nearby nodes. I want to be able to pass in a position. The position will be nodes that are close to the node that we're looking at. So this data represents this current node's position. I want to look within a radius around that. So let's say radius of 75. And I want all of the results to be put into this collection. So we'll pass this in as a reference, and this method will modify this object. Again, this doesn't work yet, so we'll have to make that work in a moment. So let's actually make this work.
Okay, so we're
Let's
actually
get
going to work
nearby
on this
nodes.
now.
This is working on our graph 2D class. So this is where that specialized behavior comes in.
So graph 2 specialized behavior.
Get nearby nodes. Vector to position, float radius, and std vector of graph 2D node pointers.
Boy, that is a mouthful. That is an absolute mouthful. So we need a vector 2 for positions, the current position. Then we need a float for the radius. And then we need an std vector of graph 2D node pointers, which we'll call
out reference out underscore nodes.
out nodes.
So that's our method signature. And again, this is a reference. It's non-constant, which means this function is assumed that it will probably modify this variable, and in our case we will be in this. So let's pop that into our CPP file. All right.
Let's pop that into a CPP. Okay, let's see. CPP is right here. So then we go into here, like, so void, probably just quickly go up here, grab this, oh wait, damn, I could have grabbed the whole thing. I didn't grab the whole thing. There we go.
So we want to loop through all of our nodes.
I wonder why the IntelliSense didn't pick that up, because I was like, bro, don't you need that thing? Where am I typing into? Oh. Typing into the video window right there. I was like, wait, what? Okay, graph. Nope. Not what we're tapping into. Here we go. Graph. 2D.
For auto node and underscore nodes. We want to know the distance of this node compared to the position. So the distance between that and the node. Float distance vector 2. We have a distance function provided by Raylib. Node data. Right. If distance is less than the radius that we've passed in, then we are going to say outNodes dot push back node.
There you go. That was the problem. Our position is spelt incorrectly. Oh my goodness. And then if dist is less than radius, then we get crazy. Nodes dot push back node. And what that's going to do is that's going to add a node to the back of our list. And now I'm thirsty. Hold on 1 second. Oh yeah, hold on. I should use my AFK screen. Bam. We'll be right back. Okay, I am back. Hopefully was not away for too long. Okay, so now we are going to be continuing the rest of this tutorial. If anyone thinks they might want me to play some nice relaxing, maybe a bit of lo-fi, you know, maybe a little bit of just rain noises, maybe a little bit of Eurobeat. I don't know. Would be funny. Okay, let's see where we're going.
So that should be a function. I think that should be pretty much it.
Wow, but that was it. I mean, granted, that is everything we need. Yeah, do I have to admit, vector, was it? I do have to, it's like Raylib is awesome how it just has functions that do things for you. It's like, otherwise, do you know how much more math there would have to be? That's the thing with programming. It like, they say, I don't know, no one ever told me to be like, hey, programming, you need math. But it's definitely, they say it's like huge math oriented, when it's more like, how much more math? I don't know, sometimes more math. Oh, math. Well, the function to get the distance between 2 points it's kind of like a right angle triangle, so you kind of need Pythagoras to work out the length of on the x, the length on the y, and then you need to do Pythagoras' theorem to get the distance. It's yeah, so we'd have to go into that, but it kind of just does it all for you, which is beautiful. Yeah, it's not a nice looking function, but certainly not the craziest.
So with this method, we're looping through all of our nodes, getting the distance between this node and all of the other nodes relative to the position. If the distance is less than the radius, we're adding it to our list. So here we go, back in application CPP. This method is now populating this list. We can loop through the nodes in this list and add them as a connection. So for auto connected node in nearby nodes. So these are the nodes that we want to connect. We also want to make sure that this connected node is not actually the node that we're already looping through. So we want to have a check that prevents us from connecting our node to ourselves. So if the node that we want to connect is equal to node, we will...
Why not write that in the nearby nodes function? That's not where you would put this. More physics than math. I mean, definitely when it comes to maybe certain things, but I wouldn't. But this kind of stuff with graphing, not much physics involved with this. Maybe when it comes to like dealing with like forces and movement, that too also involves a lot more physics than math. Not like, you don't use math and physics anyway, so. So one thing I kind of do want to do is I really don't like the way this bit's handled here. I actually want to so I probably want to actually shove it in here. So if then node is equal to it's a little bit weird, because what I want to do is I want to say that if so then we get all our nodes. So in node of m nodes, so basically we grab all our nodes. So for all our nodes, we get, and then we get a distance. And if the distance from that node is less than the search radius, then we add it to our thing, and then else and so if it's less than our radius, or I could probably, never mind. We get rid of that. So what we can then say, if it's less than our radius and the node isn't equal to itself for AI. Yeah. For AI. Hold on. So now we want to find if the node equals itself, because well, no wait, so we need, oh yeah, because we're only given a position. Yeah, so you can't actually, huh? Yeah, because you can't actually do it in here. That's a problem. Because if there's anything with the same position, I mean, granted, it would be horrible design to have a node with the same position, but you'd need to, what would you need to put into the get nearby nodes function to make it work properly? Do you think you might then the node might need more data? More than its position? Yeah, so if we go into our class here, yeah, because the only data stored in our node is its position, isn't it? What is it saying? Is that uninitialized? Okay, yes, so the only data stored in our node is its data. Yes, so there's no unique identifier for each node, so that would mean in order to determine in the get nearby nodes process would be to have a unique identifier for each node. Oh, it's going good. I'm just wondering whether I should modify the code of this bit, because the way in his tutorial, what he's done is he's created a function called get nearby nodes, where he inputs a position, makes it better. I don't know. So what he's done is he's gone and he has he inputs a position. Wait, let me do it on my end. So, okay, so we get the node's data, then which is its position. Then we input a radius, and then we have a reference to a list, right? So then what this does is it gets all nearby nodes, but there's nothing to say that the node it can classify as nearby is itself. So then in here, he's going to say in his main function, if the connected node is the same as the actual node, then draw a connection to it. Yeah, of course. You can't, as having a connection to itself is dumb. Yeah, so I was just wondering, maybe I just wanted to put it into in here instead. Because then that way it'll get nearby nodes. So then, oh yeah, because then you probably wouldn't, okay, I know what to do now. So this is what we do. So we actually, instead of getting node data, we just simply change that to node. Then we go into our here, and instead of getting that, we actually get nearby nodes, and we actually set that to node. Can we set that to node? Yes, we can. And then we call that, well, node. Right? So then we go into our CPP here, change that to node. And then we can go node data, which is its position, and then if maybe let me actually change the name here, change it to cur node or target node. Yeah, let's do target node. There we go. Change that to target node. Code the node, yes, code the node. So then if node is equal to target node. So if it's less than the radius and not equal to target node, now what is it going to say? You cannot match one is of node pointer. Okay, so then that's easy enough to change. Bam, easy come, easy go. Then so we give it the address of the node. Did I put the address in the wrong spot? No, I didn't. It's just saying it's fine. So hopefully this way it will be able to, so get nodes, mygraph.get nodes. What is mygraph.get nodes returns? Yeah, see, it puts out pointers, so no wonder it's a node pointer there. Okay, so just double checking the stuff. Average viewers, it dipped to like 3 for a while, but I think I don't know, I'd just say about 5 viewers. Yeah, so okay, so what I just did there, if just so you know, is I just changed the code just a little bit so that get nearby nodes always gets nodes other than itself. So then that way it isn't too confusing when something dumb like that happens. And I guess, you know, he did say that this code was going to be slapdash. So I was just like, no, I'm not having this. This is too much. Okay, so what's the rest of it?
So if we pass that check, then we'll say graph arrow add edge. We want to pass in node and connected node. And we need to know the data for the edge that we're adding. And for us, we want the edge's data to represent the distance between those nodes. So float distance is equal to vector2 distance, which will be nodes. So the distance between the node and the node that we're connecting to.
So node data and connected to nodes data. Node data, nope, and then connected node data. There we go. and then we add dist and smack. Oop, oop. Got the semicolon. Ooh. Oh yeah, that's just a dot.
Alright, so now we can pass that. Now if you remember, this is currently a one-way connection, so we need to make sure we add the connection in both directions.
Okay, so we're gonna do exactly the same thing here. Going to just slap connected node, and then just turn that into an N. Oop, somehow I spelled connected wrong. Oh, and I added an extra C. I wrote connected or connected.
Right. So with this, what we should see, this here, this 75, this represents the radius around. So each node, if there's a node within 75 pixels, we'll see them connect.
Oh, we're playing this now. Oh boy, this is gonna be crazy. This is scary. This is scary. We're going off the beaten path here, boys. Ooh. Could have sworn I've seen something like this in the Matrix. Lego, yes. My goodness. I swear I've seen something like this in the Matrix. Like if we quickly go into our editor here, and then we turn off, let's turn off the circles for now. Sorry, I meant, whatever, we'll just turn off the circles for now. And then we hit play. What is that gonna look like? Oh yeah, hacking into the mainframe. Yeah, look at that. Look at that. Now we're gonna make a few more tweaks just so then I can see it at its full effect. Okay, let's set offset to 0, and then we can change the number of rows depending on that spacing there. So we see screen width is that, so that means that divided by that would be 40. I think, no, 40 times 50 is way more than 100. What the hell am I talking about? No, wait. Spacing, rows, columns. Sorry, yeah, my brain is all over the place. So let's see, 50 times that's 9, so we get 9 there. And then 50 times 800 is 16, if my brain serves me correctly. Okay, now let's see how awesome this is gonna look. Oh my, okay, that's gonna look, oh. Oh. It looks like a solid gray brick. Yeah, up to, well, I mean, it's only 77 meg of RAM, so it's actually not so bad. Nah, it's 77 meg. Okay. Kind of. I don't really know what happened. Oh, that's why the YF set was off, and then 75 is... Okay, so now this should work a little more closely to what I intended. Oh, I was off by 1 on each side. So this actually needs to be a 10, and this one has to be a 17. Okay. And then that's going to look like weird. We can turn down the radius for it later, so it doesn't look like this. My God. I think I've really screwed this up. Hold on, what does his look like first? What does his look like?
And there we have it. So we now have...
Okay, so I have obviously fucked something up really bad. Oh no. What have I done? It's not too close. It's something wrong with the changes I made in this function here. So we go here. Make your bets now. Well, I definitely know it's somewhere in here, I think. So, okay, so it's gonna go around this way. Twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times. Okay, so obviously it's connecting every node to every single other node. But why? Oh no. Oh no. Oh my goodness, I forgot to change this. Okay, okay, so we actually want... That would probably be it. Okay, so we get... We probably want its distance from the target node. Okay, so now that should work properly now. There we go, look at that. Looks like tiled flooring. See, one small thing could screw up everything. That's basically what I learned in coding. You just one little thing and then bam, everything's dead. But then you just fix it and it's like, wow, mission accomplished. Yeah, boys, look at that. Look at this. Looks just too perfect. Thank you. Yes, I got it. Thank you so much for your love and support. Thank you so much, chat. I love you. Okay, let's actually continue with the video tutorial now.
Have all of those connecting, and they're also connecting on that diagonal. So I bet if we drop this down to something like, I don't know, 60,
yes,
we'll probably find that it doesn't connect diagonally now. So doesn't. So there we go. I'm going to leave it at 60. So the next thing that I want to do is I actually want to draw in our editor, in our Graph 2D editor class, I want to draw a shadow around where the mouse position is and where the next node might be. So let's go about implementing that. So we jump into our Graph 2D editor.
Yes.
We've got draw or connect.
Okay, so do it for the time being. Do we want our circles on? Yeah, we'll turn circles on.
Actions, draw all nodes. Let's go about draw a shadow node. I might call this preview node. Draw a preview node where the mouse is. Right, so if our nodes, we use draw circles, so let's say auto mouse position mouse, we'll say get mouse position. So this is a arraylib function. We should say draw circle mouse position x, mouse position y. Let's make it a little bit smaller. So what I should see with that preview.
Stop. Stop the preview. Okay, now what we actually want to do is, as much as what he's gonna wait. Oh no, I can't see it. His output window is too huge. There we go. Just like, okay, so we need to draw circle and then see mouse pause X, mouse pause Y, or I'm pretty sure there's other functions here that we can use. So there's draw circle, draw circle V. Now what you can do is, I'm pretty sure if you do draw circle V, what it's going to want from us is a vector and a radius. So instead of having to split it up, what you can do is you can just do mouse pause. Yes, so just gonna flex on him right there using the better functions here, and then he's gonna go for the light gray. But he actually, I'm pretty sure what he's later gonna do is he's gonna lower the alpha. And unfortunately, light gray has its alpha set to 255. So instead of actually going for the light gray here, what we might want to opt for instead is the colors. We'll keep the colors the same, right, with the 200, 200, 200. But then we might opt for something a little bit less intense on the alpha, which is maybe like about 100 here. And then, okay, so then let's see how this is going to go. I had a dog called... Yes. Okay, cool. So now we can see that we have a little circle here. Our little circle preview. So now, as you can see, the circle preview doesn't do anything just yet because, as he said, it's a preview. But it will be useful very soon.
We've now got a node where our mouse is. So now what I want to do is draw a line from where the mouse is connected to
an
the
infinite game
nodes that are close to that.
I mean, it's less an infinite game of connect the dots and more like a connect the dot maker.
So this is where we'll do that that vector again. std vector graph 2D node pointer
CD vector.
nearby nodes.
Great.
mgraph get.
Oh boy, this is getting crazy fast. We need more node pointers. Nearby nodes. Then we get Margaret. Oh, it's just mgraph. I'm talking about mgraph.
Nearby nodes. This time it's nearby to the mouse position with a radius of 60, I think is what we used before, and we want to populate that vector. So now what we can say is let's loop through these nodes here. Auto.
Ooh. Why is it having an issue? Oh, yes. How? Ah. Now this is where things get interesting. Okay, so now we can't make a node just yet for this. But this is what I probably should have done instead of what I did. Okay, this is what we're gonna do. We're gonna go down here. We're gonna go to our 2D graph, and we're gonna grab this whole thing. We're gonna copy it. Now what this is gonna do is now we're gonna have a function overload here. We're gonna have vector 2 position, just like the old one. Position, and then we don't have a target node at all. Okay, then we just go into here, and then we change this so that this thing now accepts a different thing. Did this freeze? No. I just took a drink. Anyway, so now it can get nearby nodes except with a position now. So we're all good. So now we go for auto. No, I know some.
Nearby nodes in nearby node in our nearby nodes list, and we'll say draw a line between the mouse position
Okay. Is there a draw line? See, there's draw line V. There we go. Now this is going to save us a little bit, so we can then go mouse. So we save us a little bit of time by going mouse position and nearby node data. Nearby node point to data, and then we set that color also to a translucent gray. So what is gray? Here gray is 130, so we can do the same thing here by going 130, 130, 130, and then 100.
And the node that was found.
Hot. Thanks. Yeah, stay hydrated, ladies and gentlemen. That's hot.
Data X. Data Y. And the color we'll have as light gray as well.
Oh,
so
it's gonna do that.
That all looks pretty good. So this is all of our code so far for drawing a preview. If we run this, what we should see now is our mouse cursor moving through, and it's showing all of the things that it's connecting to.
Awesome. You can see that here. Look at that. It's like a spider or something. What the heck is this? Oh, it's like... It's like a little crawling little thing, just like a little little creepy crawly critter. But boy, that is funky business right there. Funky business.
So this is a pretty cool fun effect. Brilliant. One more thing, and that is I want it to detect when we click on the screen. When we click on the screen, I want it to actually create a node. So now update.
This is it. This is it. Thanks, guys. Appreciate the support, guys. This is it. This is the final countdown. This is the moment. And somehow we still got 10 minutes to go. So I imagine this is gonna take a little while.
If get mouse button, what do we have? Is mouse button pressed for the left mouse button. So if we press the left mouse button, we want to get the mouse position. I'm just going to copy that from there. I'm going to get the mouse position.
So mouse button pressed 0. Then we get the mouse position.
We want to get nearby nodes when we click as well.
Yes, I did say that, but an hour of videos translates to 3 hours of talking about it. What can I say? I'm ruthlessly efficient.
And then
okay.
And we want to loop through those nodes. So let's grab our loop.
Now let's grab our loop.
And we want to connect.
And it's like, I don't know what this feeling is. I don't know if I'd call it fun, but it's certainly a very interesting feeling. Not gonna lie, it's really weird. It's a really weird feeling.
The nearby nodes. Sorry. When we click, we want to create a node, add it to the graph, and then connect any nearby nodes to that node that we created. So auto new node is equal to m graph add node. This needs the mouse position. So now we've got our new node. Now we can say graph.
Okay, graph add node. And then it needs mouse position. Okay.
Arrow. Add edge from our new node to our nearby node. We need a cost. We want the cost to be our distance. Is equal to vector 2 distance node data to nearby node data. New node.
So we have our new node data, not data, and our nearby node data or data.
So there. And again, we want that to be in both directions.
Damn, in both directions. Awesome. That second one, yeah, I'd definitely be the guy who'd forget to link it both ways.
So connect from our new node to our nearby node and vice versa. So what this should do,
Ooh, here we go.
if we run this, we should now see when we click on the screen, we've now got.
Okay, so now we can apparently create nodes. There we go. We're making new nodes, boys. Look at that. We are making new nodes. Now, there's only one thing I do want to check, and I actually want to, just for the lols, I'm going to get it on down. Okay, so you thought before we had infinite dots. Now it's going to be on mouse down. So do you know what that means? I can hold click to place dots. Now watch this. It could be like brrrr, skrrr. Big mouse go brrrr. Big mouse go brr. Big mouse go brr. Now, probably the better thing is that then what we do is we make this interesting. And for now, we remove the circles. Let's remove the circles for a moment. Now watch this. Look at that. It is art. It is legitimately art. It's like... It's almost like webbing. It's like webbing. Yes, look at my artwork. And then I can just create havoc. So it's like a sponge or something. Now I can fill up the holes in the sponge. I mean, what do you mean export the sketch? Do you mean just this image or this like program? Oh yeah, I can take a snip. That's about the best I can do. And somehow this is only using 76 megabytes of memory. Just, I'd like to point that out. Somehow this is only 76 megabytes of memory. Turn this into a print. Maybe. Optimized. Yeah, boy. This is optimized. I do see, I think the frames are dropping though. I don't know what it's doing exactly. Yeah, so I'm not entirely sure, but it looks great. It looks excellent. Yeah, so we can take a quick snip. Let's see. So we can go to use our snip tool. We got it on window mode. We hit new. Then what it's going to do, we click that window, save, capture. There we go. Windows saved. Okay. Let's see what's the rest of the tutorial.
Basic kind of editor.
It's like, look at me, just going.
A couple of stretch goals for you. So if you get through all of this, like relatively quickly, there's definitely loads of things that you can do. The first is this 60. You notice that I've used it here in my update for when I click. I've used it here in my draw function for rendering the preview, and I've used it in my application here as well when I've generated those initial values. that hard-coded 60 being in 3 different spots is horrible. So your task, create a getter and setter, and maybe a connection radius variable that is applied to your editor. So you might need to shift your editor around and use that variable in a couple of different places. So add that variable to your editor to store this value 60. Alright, so that's the first thing. So let's just write this as a to-do. Fix hard-coded 60 value representing the radius of nearby nodes to connect. That'll be the first one. The next one is, when we run it, you'll notice that for our editor, we have also hard-coded. We've hard-coded the radius of our nodes. We've hard-coded the color of our nodes. We've hard-coded the color of our lines. So add variables to customize the graph to the editor's node color, line color, node radius. If you're feeling adventurous on this, you might also say the node outline. So node color and node radius, node color, node outline. You might even want to stretch for like, can you do a
Loop de loop.
color on nodes? So for example, can you select an existing node rather than placing a node on top of it? This is actually a current problem. I can click and spam right on top. Right, so prevent spanning.
I think we want spamming.
Prevent nodes from being placed on top of other nodes. And you've got that function that we used before.
Get nearby nodes.
That get nearby nodes function, you can use that with the radius of the size that you're drawing the nodes, and if that list has got any items in it, well then you can't place something. So you've already got the function there that you can use that. So prevent nodes from being placed on top of other nodes. And then finally, this one is the real challenge. Can you
feel the love tonight?
Save and load the graph to file. So I would recommend having a look at trying to save to XML, JSON, your own custom binary format. XML is great. If you haven't done XML, this would be a great one to look into. A library to use for that is TinyXML. It can be a bit of a learning curve to get into though. So if you're struggling with things and stuff just doesn't come easily to you, skip XML. Try using the custom binary format. We've already done file IO stuff before, so I would expect that you can draw upon your existing knowledge to be able to read and write to a binary file for your graph. So give something like that a try. I'm going to leave it at that. Thanks everybody for watching. I will see you in the next video.
Okay, so that is everything Well, now we've been coding for a solid 3 hours now, so hopefully you all enjoyed. I am definitely going to be taking a break after all that hard coding. So, anyways, toodaloo. This is, I don't know. Signing off, I guess. Hope everyone has a good day. I mean, a good day, good night, and I don't know. Good afternoon, good evening, and good night. That's the words. See ya. Bye, stream. Bye, chat.